Hello everyone, welcome to today's movie. In today's movie we're going to look at how do we solve probability problems when we have the student's t distribution. And in this movie we're going to use both Excel and SPSS to solve the same problem. So let's go to Excel first. So what we have here is we're told that we have a variable t follows a student's t distribution with degrees of freedom df. What we have is we have a t value of 1.24, we have a degrees of freedom of 18, and we wish to know what the probability is that at a variable t is equal to or less than 1.24 if it is selected from this population. Okay, and to solve this particular problem, we can use the Excel function t.dist. Now, from a diagrammatic perspective, you can see there's the t distribution there. There's the t-axis. Our value is 1.24 is there. So the probability that t is equal to or less than 1.24 is the area to the left of that solid vertical red line above the t-axis and underneath the blue curve. Okay, so we can use the Excel function t.dist to solve that particular problem. Okay, and if you look at this equation, you'll see that C3 is our value of x, which in our case is t, which is 1.24. C4 is the degrees of freedom, which is 18. Because we want the probability area, then the cumulative is true. If you put that in, then this area from there, all shaded here, all the way to negative infinity, is 0.88. or 88%. Now, if you wanted to calculate, for example, the value of the function of t on the vertical axis, that point there, then you can do that quite easily by changing true to false. And if you do that, it comes out to be 0.18. So on this vertical axis there, f, the function of t, that value there is 0.18. Now, if you know the probability, 0.88455, and you want to reverse it to find out the value of t, then you can use the t.inv Excel function, as you can see on the screen. So in this case, you need to know the probability, which is 0.88455, etc., and you need to know the degrees of freedom, which is 18. So it comes out to be 1.24, which is what you would expect. Now, with SPSS, it's similar in terms of solving the problem. So if we go to SPSS, so I've got the solutions there. So the question is, how do we actually get those particular solutions? So all we do is transform, compute variable. We need to put the target in. So if we say example 9a, then all we need to do then is, because we want it's a t, remember, t distribution, we want the cumulative density function. So I want the cumulative density function, and this time I want the t distribution. So scroll down your list until you get the t distribution, which is there. Now you'll see that it wants the quant number, which is 1.24, and it also wants the degrees of freedom, which is 18. Okay, and if you click on OK, I'll overwrite that version. Then you can see that we get 0.88451. And if you compare them, you'll see that that number is the same as that number. Okay, so I'll just put the solution back on the screen again. Apologies. Okay, now you can then, if you wanted to, you could do this function. Okay, so all we do is transform, compute variable, but this time I want 9b. And this time, instead of the CDF, you want the PDF function, because you want the actual function of x, the probability of x. So it's PDF there, and then it's 1.24. So if you look at that, actually what I'll do is I'll just take that out. So I want the PDF, not the CDF this time. There we are. And this time I want the PDF for t. Okay, so I want the quant number, which is 1.24. And I want the degrees of freedom, which is 18. So again, if I click OK and overwrite the previous version, you can see I get 0.18, which is what I got in Excel. Now, if you want to go from that to that, Then again, you use transform, compute variable, but this time I'll call it C. I'll take that out, but this time I want the invert T function in SPSS. So inverse, and then inverse, and then inverse T. And this time you need to put the probability. So if I just make sure it goes in, there we are. So you need the probability. So if I just put 0.88455, and then you put the degrees of freedom, which we know is 18, and then click OK, and then click OK again. Now can you see you get 1.24? So it's quite easy to solve problems involving the t-distribution, to calculate these probability areas, etc., using both Excel or using SPSS. Or if you know the area, you know the degrees of freedom, and you want to know what the value of t is, you can do that using Excel or SPSS. Okay, that's it for today. Bye.